Good day, everyone. As you can see on this diagram, we are given that in the figure. Okay, guys, I apologize. I'm not sabone more thing. They say if in the figure AB is a diameter, here is A, and then B is a diameter. This line is a diameter, okay, and with center O, right? Guys, I always say to understand Euclidean geometry, first the statement, then we put them diagram on, right? We take what's on the statement and then we try to fill this diagram, right? So they say in the figure AB is a diameter with center O. I always say, guys, right, when they tell you about the center, right, what you need to remember, you need to maybe remember four things, right? You need to remember, if it's not four things but two things, two theorems, right? When you talk about the center, guys, right, you need to remember two theorems. Which theorem? Okay, the theorem which states angle in a semicircle gives you 90. If you see center, remember angles in a semicircle, right? Or if you see if you see center, remember angles in a semicircle. Or you can remember theorem 2 where it says okay, angle at the center is 2 times angle at the circumference. You can check this one, or you can check this one, right? If this is x, this is 2x, or this is 2x, okay, x, right? Or you can check this one if they talk yes, 2x x. So guys, whenever ba bolela ka center, ba thomba mention a center or ubona center in the diagram, remember these four things, right? So let's check the first one, if we can try to fill it up, right? Okay, we can see the center here, right? Okay, so meaning our 90 meaning our 90 will be here. And then as all busy fill up, right, guys, what you need to do, okay, we put the 90 right here, but write the reason why we put the 90 here. So the moment you got questioning what's right? So what you can say, angle in a semicircle, right? Angle in a semicircle, angle in a semicircle, semicircle. You know that's the reason why we say that, right? Okay, and then they say, okay, let's check the second one. If you have this type, if you can check, guys, we don't have this type, but you do have this one, yes, but this one you don't have. Let's check this one. Okay, let's check. Okay, this one. Okay, which one do you see, guys? Which one do you see? No, we don't have anything of this type, even this type, so we don't have at all. So we can move because triangle fill up, right? And then they say PC is a tangent to the circle at C. Okay, right now go botsa center, re go botsa tangent. Whenever we bolela tangent, right, you need to remember this one. You need to remember this one, or we wanna make it, then we fill it up, or you need to remember this one. Tangent, then you have to give you 90. Tangent, right? Okay, let's check the tangent. So let's get tangent. Let's check. Okay, let's check. Okay, let's see. And then also we are given that at angle BCP, it's x. Oh, sorry guys, I didn't fill this up. So here it's x. Here we're given that here it's x. Sorry, I apologize for that. Okay, so tangent, let's see. Because CP is what PC or CP is a tangent, right? And then the tangent, or check, okay, if maybe keep PC right here, Sansara check or arbone this angle this angle, meaning we check out this angle this angle. If moke x or moke x, right? And then reason I'm again get tan code, get tan code. It's very important, guys. From the reason want to fill up. Or I good question, whatever questions out, everything I will is tan code, right? Okay, and then okay, let's check this one. Do you have this one? Tangent, okay, let's check. No, we don't, because there's no line that you can see this line, but high mo tangent that thing I re bolela ka EP re bolela ka CP, so it's not. So this one is correct, but this one is wrong, so re tswa mo yona, right? And then they say line ODE it's perpendicular to BC. Okay, line ODE is perpendicular to BC. Okay, so guys, what happens? I work a perpendicular line. Usually, good guys, if you can check all my previous videos, the moment this word, check hore mo, right? The moment no hore. So it's the easier way to master Euclidean geometry, right? So no like a perpendicular line, right? So perpendicular line usually get Hopola theorem 1. You know hore line drawn from the like it's the line from center to chord it bisects the chord, like line from center perpendicular to chord your bisector chord. So what's this line, as you can see, right? If it amoga more chord which is BC, right? Or are clear more chord it will bisect the chord, right? It will bisect the chord. Okay, so I bisect the chord or cut the chord into what? Into two equal parts. So for you fill up these lines, I can just say it's a line from center. It's important to know the reason. So how I love the question, everything is line from center to chord, bisect the chord, right? Okay, so let's see. So right now the statements are not filled. Let's move to our questions. The first one, they say give a reason why CD is equals to DB. Why CD is equals to DB? Oh guys, already we want to say okay answer how, because of if a line from the center is perpendicular to chord, what will do, it will bisect the chord. So you can write the reason. You can say okay, the first one is because of line from center. You're not gonna go from where you so it will be easier that way. From center perpendicular to chord, bisect the chord. You are done easy. Therefore number 2, okay, let's see number 2. Do they say show that AC is parallel to OE? Okay guys, that's like what I get. Euclidean geometry, it's not that hard. It's not that I cannot say it's very easy, but I can say it's easy. Not very easy, but it's easy, right? So whenever guys like a parallel, to prove a parallel, you want to prove it's either to prove a corresponding. You want to prove that if this angle goes to this, if you maybe get x more get x, then you can do what? You can conclude by saying, okay, this line is parallel to this line. Right now, let's use those letters are different one, but show that AC, okay, let's maybe write that this is AC is parallel to what? OE. Okay, let's say this is OE. So if more AC and OE, therefore we're going to conclude that they are parallel because of what? Corresponding. I grab like a fine, right? Okay, or you, okay, if maybe this is AC, O king, it's AO, okay, and CE. If we can add this triangle, the interior, chance to 180, right? Therefore, we can conclude the parallel, right? Or you can use math is what is fun, right? So alternating. If it is AC, OE, if this angle here, this angle here, therefore we're going to conclude the parallel. Why? Alternating angles. Okay, let's see what between corresponding interior le alternating, which one I got to prove this thing. Okay, let's see. Okay, so this is AC over OE. Are check out corresponding. Okay, so we're going to correspond to angle. If guys are here, we're given that this line is perpendicular to this line, right? Meaning 90 degrees. Ne? So if you know angles on the same angles on a straight line, santo differ 108. If more 90, santo this angle here, differ 180. So 180 minus 90 get 90. So we're making also 90, right? So get 90 here, right? So guys, on a angle to one more this line corresponding. Okay, you can draw. If una angle to one this one all those lines recheck corresponding. Okay, use this color kono but or na mo ditwana cause level F yare nane this thing here can either be this f, right? So the first f alien, so right, as you can see, right? So guys, our level f is different. It's like this line here, guys, right? So it's like, go guys, maybe on so, right? First f how ke f lebeletseng kwa, right? Ke f faces in that direction, and then the second f how ke f faces in what, that direction, right? So mo ke drawile the mo ke green, lime green, ke f faces in that direction, and then mo ke tlo drawing ke use this pink line, ke f faces in that direction, right? So how do f tsa na corresponding now? I talk about the pink one because faces that direction. So mo pink one, maybe this angle equals to this angle. If you can check, more than 90, more than 90, meaning that what, they are equal, they are correspond, right? So to show that AC is parallel to OE, we can say okay, because of C angle, we can say angle, okay, let's start or what's our, this is 90, right? Let's go conclude, right? So let's say D1 equals to 90, angles on a straight line, angles on a straight line, on a straight line, they add up to what, 280, right? And therefore we can say, you can conclude by saying ACB is this angle, right, is equals to O, okay, we can say D1 because here was D1, right? Both equals to 90, right? Guys, so one of the reasons very important, right? Because sometimes abamake fella answer to how the reasons are how important, both of them equals to 90, right? Therefore we can conclude by saying, okay, therefore AC is parallel to what, to OE. What's the reason? The corresponding angle, we have proved that, because this is 90 and this is 90. Oh, right. So guys, if they're corresponding, therefore we can conclude that there are those lines that are corresponding. What are these lines that what, they're corresponding, right? So if these lines that are corresponding, or f it's parallel, right? So if a corresponding, or this x, most and x, if these lines are what, are parallel, or most and x, I get 90 more about 90, or move make x most and x, I work ka f which if is in that side, right? So okay, x, right? Okay, x. Okay, let's move to the next question. If BCP equals to x, name two other angles equal to x. Okay, name two other angles equals to x. Oh, if BCP equals to x, name two other angles equals to x. Okay, 3. I like this one. Equals to x. Equals to x. So here gets necessary message or again x. So we can say the first one that equals to x, angle A. Angle A equals to what? Get the A get this here, guys, equals to x. Guys, it's important reason how side name. Right now you say, you just say tan code. You don't need to panic or oh, you know how it's tan code. Okay, let's move. And then but to name two other angles equals to x, also this one equals to x. Therefore you can say angle A equals to angle EOB, right? The corresponding angle, corresponding. Why would they correspond that? Because of AC it's parallel to OE. It's important, guys. So you can't just write corresponding or just write alternating. What's about or why or they correspond? Show that also is because of AC is parallel to OE. Therefore, what to believe? Because right now it's valid right now, right? Therefore, if you mean that way, meaning also EOB equals to x. So two other angles that equals to x, this angle and this angle. Okay, let's move. The last question. Prove that OBEC is a cyclic quadrilateral. Oh, guys, whenever I prove a cyclic quadrilateral, if maybe you haven't watched my previous videos, you can go and watch them. But right now, let me try to summarize a little bit. That's the next video. Okay, prove that OBE is a cyclic quadrilateral, right? Guys, so prove that something is a cyclic quadrilateral. You can either use this, let's say, okay, the 3 ways you can prove something in this cyclic quadrilateral. Once I prove those, Therefore, you can conclude by saying this the cyclic quadrilateral. You can either prove ka angles in the same segment. If you want something says so camera circle how, you can either prove for if we want this angle this angle. Therefore, you can conclude by saying the cyclic quadrilateral, right? Or if it's like this, and then see this one, this one. If you say A, B, if you add that A plus B, they are over 180. You can conclude by saying the cyclic quadrilateral. Or if, apologize, if this angle equals to this angle, if maybe more when I look at x, more by x, you can conclude by saying the cyclic quadrilateral. So I have to make the first one, right? I have to make 1, 2, 3. Re bona gore ke finger to some prove the cyclic quadrilateral. Okay, so but focus on which? But focus on OBEC. OBEC. Okay. Okay, let's just do this. Okay, let's just focus on this. Okay. Mo OBEC, go na le ntwe re bonang tse di tshwanang. Go na le se se re se bonang se se tshwanang. Okay, maybe re bua ka the first one. Re bona this kind of thing. Angles in the same segment. Maybe more bona X or re bona Y or re bona 90 or re bona 90. Tse di tshwanang. Look properly. Oh yes, if you can check very carefully, check it guys, right? This one is equals to this one. One. Therefore, you can conclude. Guys. Alright, can you see? If you're not more confusing, you can comment down below. I can try to start again. I can try my best. Therefore, you can understand, right? Okay? So, we can say, okay, number 3, we can say, what? We can say angle BCE. I cannot just say angle C, guys, right? I have to say angle BCE to show that I'm talking about this angle. The moment the guys angle, this angle, let's say you just say C. The whole thing, say, guys, this whole thing. Now I'm not talking about this whole thing, I'm talking about this. You have to be specific. BCE, right? And then also what? Angle EOB equals to angle EOB. Both equals to X. Both of them equals to what? Equals to X. Therefore, okay, what did they say? Therefore, OBEC is a cyclic quadrilateral, right? Why do you say it's a cyclic quadrilateral, right? Angles in the same segment. Angles in a, okay, let me write this here. Angles in the same segment. I have shown that we have angles in the same segment, right? Let's see. So guys, thank you for watching. You can please like, comment, and subscribe if you're new to the channel. If please comment down. I'm here to help any chapter. Peace.